Hey everybody, today we're going to solve the unique binary search trees problem on LeetCode. Problem description is given n, how many structurally unique binary search trees are there that store the values 1 through n. So, for an example input of 3, the output's 5, and here are what the 5 trees look like. So, this problem's pretty simple once you think about it recursively. So, for each number 1 through n, if we make that number the root, then there will be a certain number of left subtrees and right subtrees, and we can recursively solve that number. And then the total number of trees with that number as the root will be the number of left trees times the number of right trees. So here's how we implement this. Here's the original method that LeetCode gives you. We just return a helper function. And what we do is we pass it the range, which starts at 1 to n, and a integer array for a memoization pad. So we don't resolve problems we've already solved. And then in here, if low is greater than high, we return 1. So the only tree when the lower number is greater than the higher number is the null tree. So that's the one tree that can happen in that instance. If we've seen this problem before, if memo of low of high is not 0, it's in our pad somewhere, we just return memo of low of high. Then down here we have to actually compute the answer, so we start this total trees, and then we loop from low to high. And I in this instance is the value of the root of the tree. So at each loop, I is considered to be the value of the root of the binary search tree. We recursively solve the number of left subtrees and the number of right subtrees for a root with value I, which is for left would be low, I minus 1 is high, and then for its right subtrees would be I plus 1 and then high, because everything in the left tree would have to be less than I, everything in the right tree would have to be greater than I. And then the total trees sum just goes up by the left subtrees times the right subtrees. And that's because for each of those subtrees, we could have them combined together, okay? So, yeah, each of those different combination of trees have to be counted. So the sum increases by the product of the number of left subtrees and the number of right subtrees. And then at the end, we just memoize our answer, so we're going to solve it again and return the answer. So that's all there is for this one. Like I said, it's pretty simple once you start thinking of it recursively. The biggest thing here is if you don't memoize your answer, if you just write a recursive function, you'll time out. So just remember to use dynamic programming to memorize your recursive solutions.